Hello, welcome to 1.7 Quadratic Equations. A quadratic equation in one variable, an equation that can be transformed into the form ax squared plus bx plus c equals 0, where a, b, and c are constants, they're real numbers, and a is not 0. If a was 0, it wouldn't be a first term, you'd have a linear equation. So these equations are also called second degree equations because the highest power on the variable is 2. The name quadratic comes from the Latin word quadrus, meaning square. So solving quadratic equations by factoring, the zero factor property, if a times b is 0, then either a is 0 or b is 0 or both are 0. The first thing you're going to do is transform the quadratic to look like this: ax squared plus bx plus c equals 0. If the quadratic is factorable, factor it and set each of the factors equal to 0. So the first way to solve these equations is by factoring. And we're pros at factoring by now, I'm sure. So x squared minus 14x plus 49, that's going to be x minus 7 squared equals 0. If you want to see that break down, you put the 49 here, the negative 14 here, so we get negative 7, negative 7. X minus 7 times x minus 7 is 0. So set x minus 7 equal to 0, you get x equals 7. That's the solution to this one. And there's only one solution for that one. From the next one, I'll subtract 4x squared, subtract 6x, and add 1. We'll have x squared minus 4x plus 4 equals 0. And we can factor this as well. 4, negative 4. The x minus 2 times x minus 2 equals 0. So x minus 2 squared is 0. Set x minus 2 equal to 0, so x equals 2. That's our solution. Moving on. Another technique can solve them by the perfect squares method. When the expression containing the variable is squared, you can take the square root of both sides. Be sure to check for both the positive and negative square root of the constant. So if a squared equals c, then a equals plus or minus square root of c, where c is a constant, and there can be no variables outside of the square. So in this one we have 2x plus 1 quantity squared minus 7 equals 0. If we add 7 to both sides, we have 2x plus 1 squared equals 7. Now we take the square root of 2x plus 1 squared. That's equal to plus or minus the square root of 7. So 2x plus 1 equals plus or minus the square root of 7. 2x equals negative 1 plus or minus the square root of 7. Solving for x, we'll divide by 2. X equals negative 1 plus or minus the square root of 7. The entire thing is divided by 2. And this is two answers: negative 1 plus the square root of 7 over 2, negative 1 minus the square root of 7 over 2. The next one, x squared minus 6x plus 9 equals 25. This first part over here can be factored to be x minus 3 squared equals 25. So do the square root of x minus 3 squared equals plus or minus the square root of 25. So x minus 3 is plus or minus 5. We add the 3. X equals 3 plus or minus 5. That means x equals 3 plus 5, which is 8. X equals 3 minus 5, which is negative 2. So x is negative 2 and 8. Or I should say or 8. Can't be both at the same time. The next one. Solving quadratic equations by completing the square. Write the equation ax squared plus bx plus c equals 0 in the form ax squared plus bx equals negative c. So we're going to make a perfect square trinomial here. So we take this b divided by 2. Now we have a leading coefficient of a, we've got to divide that through. So x squared plus b over ax equals negative c over a. Take the coefficient for x, we're going to divide it by 2 and square it and add that to both sides. Because that's the coefficient for x, half of it then squared is your constant in a perfect square trinomial. So divide the coefficient by 2, square the result, add this to both sides. The left side then is a perfect square trinomial, and it factors down to be this: x plus b over 2a squared minus then c over a plus b over 2a squared. Now take the square root of each side. And I know this process tends to frustrate students, and reading this and even going through this now probably makes people feel very overwhelmed. We're going to do some examples, and hopefully it'll be a little more concrete. I have had students in the past say, why do we have to learn this? Well, first of all, it's important to learn because it's important to learn. But we are going to use this when we get to circles and we have to complete the square. So completing the square is not this trivial little technique. It is important to know. Plus, we're going to learn about the quadratic formula. Well, we can't use the quadratic formula unless we know this. I should say, it is derived from knowing this. This process derives the quadratic formula. So, again, it's not a trivial process. So example 3 says, solve the following quadratic equations by completing the square. Okay, so we're going to add the 3 to both sides. 5y squared plus 6y minus, or equals positive 3, I should say. Divide everything by 5, the leading coefficient. Y squared plus 6/5 y equals 3/5. So our b, our coefficient to the linear term, the y in this case, is 6/5. We take 6 over 5 and divide it by 2 and get 6 over 10, which is 3 over 5. Then we square it. That's going to be 9 over 25. So the left side becomes y squared plus 6 over 5y plus 9 over 25 equals the right side, 3 over 5 plus 9 over 25. So it'll be y plus 3/5. This is the square root of the 9/25 squared. This is now a perfect square trinomial. We have created a perfect square trinomial. Equals, and if we want to combine these, that's going to be, what, 15/25 plus 9/25 is 24/25. So the square root of y plus 3/5 squared is the square root of 24/25. So y plus 3/5 is, I should say plus or minus the square root of 24 over 5. And we can continue solving for y. Y is negative 3/5 plus or minus square root of 24. You can pull a 4 out of that, so it would be 2 times the square root of 6 over 5. So we're looking at negative 3 plus or minus 2 times the square root of 6 over 5. And there's your answer. Those are 2 answers. And the next one, I'm going to add 10 to both sides. 2x squared plus 6x equals 20. Divide everything by 2. X squared plus 3x equals 10. So my b here is 3. 3 halves. We'll take that divided by 2, and we're going to square it. That becomes 9/4. So this is x squared plus 3x plus 9/4 equals 10 plus 9/4. So I added it to both sides to keep the equation balanced, to maintain the equality. This right here, this x squared plus 3x plus 9/4 is a perfect square trinomial. That we've created it that way. That becomes x plus 3 halves squared equals 10 plus 9/4 is going to be 49 over 4. So I take the square root of both sides. X plus 3 halves is plus or minus 7 halves. We'll subtract the 3 halves. So x equals negative 3 halves plus or minus 7 halves. X is negative 3 plus or minus 7 over 2. And we can actually go further. Negative 3 plus 7 is 4, so we have 4 over 2, or negative 3 minus 7 is 10, negative 10 over 2. So it's 2 or negative 5. So that is the completing the square. We've completed the square, making perfect square trinomials right here, becomes that. Made a perfect square trinomial here, it becomes that. And then we can take the square root. So I'm going to move on to the next concept, so feel free to pause this if you need to. Okay, here we go. Next, solving quadratics by the quadratic formula. Now the quadratic formula, solution of the equation ax squared plus bx plus c equals 0 are x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And the equation has one solution if the part under the radical is 0. The b squared minus 4ac, that's called the discriminant. If that's 0, it has one solution. Has two solutions if the part under the radical, the discriminant b squared minus 4ac is positive. That's two solutions if the discriminant is positive. That's two real solutions. It has two complex solutions and conjugates of one another if b squared minus 4ac is negative. Why? Because we'd be taking the square root of a negative. So if this part, the discriminant, is negative, you have two complex solutions. And again, that part under the radical is called b squared minus 4ac is the discriminant. And if you type this in Microsoft Word 2003, it'll come up with an error. I'm not sure about 2007 or 2010. Anyway, so let's solve this equation by the quadratic formula, these next two. The idea is to get everything on the same side, a little bit different than the completing the square. 3x squared plus x minus 4 equals 0. So my a is 3, my b is 1, and my c is negative 4. So x would be negative of b, that's 1, plus or minus the square root of b squared, 1 squared minus 4 times our a is 3, our c is negative 4. All over 2 times our a is 3. So x would be negative 1 plus or minus the square root of 1. So negative 4 times 3 is negative 12 times negative 4 is positive 48. All over 2 times 3. So x is negative 1 plus or minus the square root of 49 over 6. Negative 1 plus or minus 7 over 6. Negative 1 plus 7 over 6, or negative 1 minus 7 over 6. Now negative 1 plus 7 is 6 over 6, which is 1. Negative 1 minus 7 is negative 8 over 6, which is negative 4/3. So x would be equal to 1 or negative 4/3. These are solutions to our original equation. So again, once we get everything to one side, we identify the a, the b is 1, and the c is negative 4. We put it into the formula, and boom. And for the next one, we're going to have to subtract 51 from both sides. So we have 7x squared minus 4x minus 51 equals 0. So the a is 7, the b is negative 4, and the c is negative 51. So x would be negative of negative 4 that's negative b, plus or minus the square root of negative 4 squared, minus 4 times a is 7, c is negative 51, all over 2 times a. Oh, our a is 7. And the square root needs to extend all the way. So this becomes 4 plus or minus the square root of 16 plus 1428 over 14. So it looks really bad right now, doesn't it? And it's 4 plus or minus the square root of 1444 over 14. Now, the square root of 1444, luckily, is 38. So that's going to be 4 plus 38 over 14, or 4 minus 38 over 14. 4 plus 38 is 42 over 14, which is 3. 4 minus 38 is 34 negative over 14, which is negative 17 over 7. So our answers are 3 and negative 17 over 7. Go on to the next page. I have an application problem. So feel free to pause if you need that paused. Here we go. A slingshot is used to shoot a BB at a velocity of 96 feet per second, that's the initial velocity, straight up from the ground level. When will the BB reach maximum height of 144 feet? So imagine we're shooting the BB from ground level, time 0. It's going to go up, come back down. And what time will it hit the ground? This is time 0 here. We want to be at 144 feet. So use the formula h equals negative 1/2 gt squared plus v naught t plus h naught. So our h is going to be negative 1/2. Now g is 32 feet per second squared. That's the velocity to gravity. Sorry, acceleration to gravity. So we have 32 here. T squared plus our initial velocity of v naught is 96, so that's going to be 96 t plus, and our initial height is 0. So h would be negative 16 t squared plus 96 t. So we're looking at h being 144. The height being 144 is negative 16 t squared plus 96 t. So 0, if you bring this over, is negative 16 t squared plus 96 t plus, I should say, minus 144. And we'll divide everything by negative 16. So 0 equals t squared minus 6t plus 9. This becomes 0 equals t minus 3 squared. So t minus 3 equals 0, t equals 3. So after 3 seconds, you're going to be at the peak. Okay, feel free to pause if you need some more time there. Oh, by the way, let's think about this. 3 seconds are there. How much to come back down? Another 3 seconds, so 6 seconds. Okay, I'm going to move on. Feel free to pause. So solving quadratic-like equations. If you have something of the form a times some expression squared plus b times that expression plus c equals 0, you can factor out or substitute and then solve. So solve. First you're going to solve for the variable, solve for a, capital A, then solve for the variable in a. So in this first one we have x squared plus 1 squared plus x squared plus 1 minus 12. So let's say that our a is x squared plus 1, then we have a squared plus a minus 12 equals 0. This factors to be a, now if you want to do the factoring diamond style, negative 12 up here, 1 down here, so this is a 4, negative 3. A plus 4 times a minus 3 equals 0. A plus 4 is 0, so a equals negative 4. A minus 3 is 0, so a equals 3. Now I'm going to substitute this x squared plus 1 back. X squared plus 1 equals negative 4. X squared equals negative 5, and x would be plus or minus the square root of negative 5, or x is plus or minus I times the square root of 5. Let's solve the other one. X squared is at plus 1 equals 3. X squared equals 2, so x would be plus or minus the square root of 2. So our solutions will be plus or minus the square root of 2, plus or minus I times the square root of 5. Moving on to the last page in this section. So feel free to pause that if you need to pause that. Okay, we have examples 7 and 8 to do. Solve the following polynomial equations by factoring. A cubed plus or minus 3a squared equals a minus 3. We have 4 terms here. I bring all the terms to one side. You have a cubed minus 3a squared minus a plus 3 equals 0. So if you were to factor by grouping a cubed minus 3a squared minus a minus 3 equals 0, out of the first pair we can pull an a squared. Can't pull anything out of the second pair, so I'll just put a 1 out front. So this becomes a squared minus 1 times a minus 3. And we can factor the first pair, a squared minus 1, to be a minus 1 times a plus 1 times a minus 3. So we have 3 linear terms. A minus 1 equals 0, a plus 1 equals 0, a minus 3 equals 0. So a equals 1. A equals negative 1, a equals 3. Okay, now we're going to work on part B to this. 14x cubed plus 27x squared minus 20x equals 0. From this we could factor out an x from every term, and we'd have 14x squared plus 27x minus 20 equals 0. So we have to factor this quadratic now. Now we could use the quadratic formula, or we can try factoring this. Let's look at 14 times negative 20. That's going to be negative 280. So we want some factors of negative 280 that add to be positive 27. So that means the larger of the two, its absolute value would be positive. I should say the larger of the two absolute values of the two terms. So one's negative, one's positive. So if it helps, we could start here. Negative 1, 280. Negative 2, 140. Negative 3. Will negative 3 work in that? No, I don't think so. Negative 4 will. 4 times what is 280? That's going to be 70. Okay, we're getting closer. Let's try 5. 5 times what is 280? I want to say 56. Yeah, 56 would be it. How about 6 wouldn't work? 7 would work. Negative 7 times what is 280? And I believe that would be 40. How about 8? 8 would work. Negative 8 times what is 70? No, sorry. Negative 8 times what is 280? 35, and I think that's our pair right there. Negative 8 plus 35 is 27. Negative 8 times 35. Let's double check that. Yep, 280. Okay, so that means we're going to have x times the quantity, 14x squared minus 8x plus 35x minus 20. Now I want to do some parentheses around here like this. So we'd have x times the quantity. What can we factor out of 14x squared minus 8x? I think we can do a 2x. And we have 7x minus 4. Out of here we can pull a 5 and we'd have 7x minus 4. So we have x times 2x plus 5 times 7x minus 4 equals 0. So it's x equals 0. 2x plus 5 equals 0 means 2x is negative 5, or x is negative 5 halves. 7x minus 4 equals 0 means 7x equals 4, or x equals 4 sevenths. So our solutions, values that make this a true statement, x equals 0, x equals negative 5 halves, and x equals 4 sevenths. So go ahead and pause it if you'd like. We're going to go on to the last one from this section. This one says, solve the equation by factoring. Okay, now we have 3x to the 11 thirds plus 2x to the 8 thirds minus 5x to the 5 thirds. So what is the smallest power on x? And it's x to the 5 thirds. So I could factor that out, x to the 5 thirds times 3x to the 11 thirds minus 5 thirds is 6 thirds, which is 2, plus 2x to the 8 thirds minus 5 thirds is 3 thirds, which is 1, minus 5. So it's x to the 5 thirds times 3x squared plus 2x minus 5. So we have, let's see, 3 times negative 5 is negative 15. Factors of negative 15 that add to be 2, well, how about negative 3 and 5? So we have x to the 5 thirds times 3x squared minus 3x plus 5x minus 5 equals 0. So it's x to the 5 thirds times what? Out of the first pair we can pull a 3x. And maybe I'll do it in steps first, I'm sorry. 3x squared minus 3x plus 5x minus 5. I'm going to move up to here. It's x to the 5 thirds times, pull a 3x out of the first pair, plus, pull a 5 out of the second pair, and we have x to the 5 thirds times 3x plus 5 times x minus 1. So if you set each factor equal to 0, x could be 0. 3x plus 5 equals 0, so 3x equals negative 5. Or x equals negative 5 thirds. X minus 1 equals 0 means x equals 1. And that'll do it for 1.7 quadratic equations. Hope you enjoyed that. I hope that brought back a lot of memories, a lot of good memories. So send me your questions. Thanks.